Hello my dear friends, a good evening to all of you. I welcome you to the ACE online platform. Now, as per our schedule SSC JE revision series, today we are going to discuss about environmental engineering subject. Okay? Let's start. As you can see here, myself I am Abhishek, a faculty of ACE Engineering College, ACE Engineering Academy. Okay. This is a revision series for environmental engineering subject. Okay. Before dive into the subject, let me brief you about its syllabus and what is the weightage of this particular subject. Okay. Let us look at this. The syllabus for environmental engineering is this. See, you can see environmental engineering syllabus they have mentioned in official portal of SSC, right. See, as you can see, quality of water, sources of water supply, purification of water means treatment of water, distribution of water, the need of sanitation, this is introduction to wastewater engineering, sewerage systems, circular sewer, oval sewer, sewer appurtenances, sewage treatment, surface water drainage and solid waste management as well as air pollution and noise pollution. This is the piece of syllabus they have mentioned in our official portal, right. Okay. Let us discuss about what is its weightage, right. Okay. Coming to this weightage of environmental engineering for your SSC JE exam, we have a very good number of questions. As you can observe here, I have taken last 3 years, the latest 3 years weightage for SSC JE environmental engineering. As you can see here in 2021, in 2 different sessions, morning and evening session, 9 number of questions, 9 and 9, right. In 2022, 4 sessions, almost close to 8, 8, 6, 8, 9, right. Each session the number of questions are displayed here, right. Coming to 2023, the last year, we can see 4 different sessions they have conducted the exam, in which 8 number of questions, 9 number of questions, 10 number of questions and 7 number of questions. We can say on an average this environmental engineering weightage for SSC JE exam, we can say 7 to 9 questions, right. 7 to 9 questions is the weightage for this particular subject, right. This is a very good weightage. Now, see for your SSC JE, it is for 200 marks, paper 1, in which technical subject is for 100 marks. In that 100 marks, environmental subject is almost 9 questions, right. It is very good weightage here, right. See, let me tell you, in this in this kind of central services, the time is very important factor. Let us see, see I told you 200 questions in the paper 1, right. 200 questions for 2 hours. 2 hours means 120 minutes. In 120 minutes, you needs to complete 200 questions, in which 100 is general studies and remaining 100 is for technical subject. See, each question is having just 0.6 minute of time. It means what? 36 seconds. See, in these kind of exams, you must have speed as well as accuracy, right. Speed and accuracy plays an important role. Time is very crucial in these kind of exams to crack, right. Okay, this is all about syllabus for environmental engineering as well as the weightage, and we can say we need to complete each question in less than 36 seconds, right. Try to complete in a half minute, try to solve, try to adopt like that, so that you can able to complete all the questions in this particular exam. Okay. Let us dive into the environmental engineering subject, right. Okay, let us look at this. I will start my discussion by considering previous year SSC JE and some questions which are in standard with SSC JE I have taken. With these help of these questions, I will discuss as many concepts as possible in this 1 hour session. Try to utilize this session for your revision. Okay. Let us look at the first question, water demand and population forecasting, right. Which of the following method is used to forecast the population of a city with a large scope of expansion, with a large scope of expansion. See, try to solve in 36 seconds. I will see how many of you can able to give the correct answer. See, very easy. Which of the following method is used to forecast the population of a city with a large scope of expansion? Large scope of expansion. What is that method? Try. Okay, let me give you the answer. With a large scope of expansion, we use geometric increase method, right? Geometric increase method is used to the criteria of the city is like this. Let us have a brief idea of the city for which we use some different kinds of forecasting methods. Look at this. We have a population forecasting methods here and the criteria of the city, right? Okay, just look at the arithmetic increase method is used when the city is old or a settled community, right? When the city is old and settled communities, we go for arithmetic increase method. If it is geometric increase method, young and rapidly expanding cities, when the city has a scope of expansion, further expansion, then we go for geometric increase method. Young and rapidly expanding cities, geometric increase method. What is incremental increase method? Whether the city is old or new, we can go for incremental increase method. Okay. The next, decreasing rate of growth method. Where we can use this method? When the population shows downward trend, it means when the population reaches towards the saturation, we can go for decreasing rate of growth method, right? These are the various population forecasting methods and their applicability to the concerned city, right? With this, you can have some idea, right, which method is adopted to what kind of a city, right? Okay, the next question. See, very easy. Try to solve in 36 seconds. Calculate the population by the end of 2011. By the end of 2011, by the arithmetical increase method, he is specifically asking solve this population forecasting by arithmetical increase method. He has the given data. This is the year and corresponding population. What is the population in the year 2011 by arithmetic increase? Try to solve. Very easy. Okay, let me solve now. See, here he has given year and the corresponding population, right? He is asking you to estimate population at the end of 2011 by arithmetic increase. What we can do here? We can say increase in population we need to calculate, right? Increase in population, right? See, this is 1 lakh to 1,09,000. How much is increase here? 9,000. I am indicating 9k means 9,000. Okay. 1,09,000 to 16,000. How much is increase here? Here 7,000, right? 7,000. Here 1,16,000 to 28 means 12,000. Therefore, this is increase in population as per the arithmetic increase method. We need to estimate x bar. What is x bar? Average increase in the population. Average increase means 9k, 7k, 12k divided by 3, right? See, 9,000. I am indicating k means 1000 only. 7k plus 12k divided by 3. This is the x bar value. How much is this? 9 plus 7, 16 plus 12, 28,000, right? 28,000 divided by 3. This is x bar. Don't solve. Keep it as it is. Without calculator, you need to solve, right? This is the x bar value. What I need to estimate population in 2011. See, 1981 to 2011 is 30 years, right? 1981, 91, 2001, 2011. Therefore, 3 decades. Are you getting my point? N is equal to 3 decades, 2011. Then P 2011 as per arithmetic increase method is Pn is equal to P naught plus N into x bar. What is P naught? Last known population. 1981 population is last known population to us, right? 1,28,000. 1,28,000. What is x n value? 3 decades. What is x bar? 28,000 by 3. Don't solve that 28,000 divided by 3, right? Here you can easily get 3 cancel. 1,28,000 plus 28,000. 1,56,000 is the population, right? Which is matching here? Option B, Bombay is correct, right? Simple, you can able to solve these kind of questions, even though they are numerical kind of questions, you can easily solve in less than a minute, right? Simple numerical only they are asking. Okay, the next question, look at this, very easy. If you can have some idea, you can simply pick the answer in just 2 to 3 seconds, no need of 36 seconds here. Like the subjects like environmental engineering, you can save more time, right? Look at this, the total water requirement of an average Indian city is, what he is asking, by considering domestic, institutional and commercial, industrial demand for public use and losses all put together we can call it as total water requirement, right? He is asking the total water requirement of an average Indian city. What is the total water requirement of an Indian city? Total is 270, right? This is correct option. Option B is correct, Bombay, right? See, let me give you a brief idea about all water requirements. See, total demand as per IS 1172/1993. See, my dear friends, please note this Indian Standard Code, it is very important code. They may sometimes ask you directly what code, Indian Standard Code is recommended for a water requirement. They may ask you directly, Indian Standard Code 1172/1993 is a water requirement code. Directly they may ask you the code also. Remember 1172/1993. See, as per this code, what is total demand? See, we have all the water requirements here. See, what is domestic use? As you all know, 135 LPCD. What is institutional and commercial use? 20, on an average we take 20 LPCD. These are in LPCD demand. What is industrial? 50. What is public use? We consider a nominal amount of 10 LPCD. What are losses? To compensate losses and thefts, we have 55 LPCD. If you sum up all these water demands, you will get 270 LPCD. For an average Indian city, total water demand is how much? 270 LPCD. 270 is the correct answer, right? See, if it is for a full flushing system, only this will vary. What is this? Domestic water demand, right? This domestic for a full flushing system, it is 200 LPCD, right? For a full flushing system, domestic water demand is 200. If you add 200, remaining are same, then you will get 335. For a full flushing system, total demand is 335. Here it is 270, you need to add 65, right, to get 200. Therefore, 270, 65, 335. Are you getting my point? It is for average Indian city, it is for a full flushing system, only the domestic demand varies. This is about that particular question. Okay, the next question. See, it is also very easy to solve. Just try to solve. Give me the answer. What will be the fire demand for a city having population of 4 lakh by Kuchling's formula? What he is asking? This is the population. What will be the fire demand for a city having the population of 4 lakh by using Kuchling's formula? What is the Kuchling's formula of fire demand? As you all know, fire demand by Kuchling formula Q equal to 3182 root P. What is P here? P is the population in thousands, right? He has given population in 4 lakh. 4 lakh means P will be 400 only, right? It is Kuchling formula. 3182 under root 400 means 4 lakh he has given, in thousands I needs to substitute. 3182 multiplied with 20 only. What is this value? Double of this, 6364 and 0. What is the unit? Fire demand we must have, it is an empirical formula. P is in thousands, Q is in liter per minute. Therefore, 63640 liter per minute. Are you getting my point? Therefore, which option is matching? Chennai, right? 63640 liter per minute, right? You can easily solve within the stipulated time, right? Within 30 seconds you can able to solve. Simple numerical answer, numerical questions only they are asking, right? Okay. Let me give you a brief idea about all fire demand formulae, right? Let us have that slide now. Estimation of fire demand by an empirical formula, right? Let us have a look here. We have a Kuchling formula, just now I told you 3182 root P, Buston 5663 root P, Freeman 1136 P by 5 plus 10, Freeman formula. National Board of Fire underwriters formula is 4637 root P into 1 minus 0.01 root P. This is what National Board of Fire underwriters formula, which is less than 2 lakh population. If the population exceeds 2 lakh, we have this provision, which is for 54,600 is made with an extra additional provision of this. This is an extra provision for a National Board of Fire underwriters formula. These are all fire demand formulae, my dear. Here Q is in liter per minute, the population in thousands. In all fire demand empirical formulae that I have displayed here, Q means in liter per minute. Q is what? Fire demand in liter per minute. What is P? Population in thousands. That is what we have discussed. Next, try to solve this question. Which of the following is taken as hourly variation factor? Please pay enough attention here. Which is the hourly variation factor? He is not asking the peak factor, he is asking the variation factor. Just look at the options. The hourly variation factor is 1.5, right? You can easily solve. 1.5 is the correct option. See, just look at this. We have maximum hourly demand of the maximum day. What is that? Q max hourly. Q max hourly generally 150 times, it means 150%, it means 1.5 times average hourly demand of the maximum day. It means what? Average hourly means maximum daily demand by 24. Daily divided by 24 will give the average hourly demand only. What is maximum daily? 1.8 times average daily demand. Now you will get the peak factor. This is the peak factor, but he is asking what is the variation, hourly variation. Hourly variation factor is 1.5. This is you needs to select. 1.5 is the correct answer. It is the peak factor. This maximum hourly demand of the maximum day, also known as peak demand. Okay. Just look at the factors now. This is the maximum demand I have listed here, and these are the peak factors. These peak factors are also known as Goodrich peak factors. What is that? Goodrich peak factors. These are Goodrich peak factors. What is peak factor for maximum hourly demand? 2.7. Daily is 1.8. What is weekly? 1.48. Monthly 1.28. As you can see, there is decrease in the peak factors. You can remember in that way. Hourly demand 2.7, daily 1.8, weekly 1.48, monthly 1.28. It is decreasing peak factor. The time is increasing, the peak factor is decreasing. In this way, you can remember these values, right? This is about peak demand. Let us have a simple question from sources of water. Just look at this question, very easy. Simply in 2-3 seconds you can pick the option. Which of the following is a subsurface source of water? The options given are these, right? See here, lake and river and stream, all these are surface water sources, but a spring is a subsurface source, right? You can easily solve in 36 seconds, right? This is what? Lake. Lake is a still water body, the water body which is at rest condition. But the river and a stream are running water bodies, right? These are all surface water sources. Which is subsurface source here? Spring, right? You can easily select. See, generally spring means, let me explain this. There is a natural topography is like this. When the natural topography is like this, we have water table. This is what? Water table, groundwater table. When the groundwater table is like this, for this natural topography, the water movement, groundwater movement is like this. If the groundwater is moving like this, this is the leading water, this is the tailing water. What happens is, it has an obstruction to the water, right? Water can't move out of this. This is an obstruction. When the movement is like this, this tailing water exerts pressure on this leading water. This water is under tremendous pressure. Due to this tremendous pressure, the ground got punched here. Small tiny opening happens due to this tremendous pressure. Once the ground got punched, water oozes out of that punch like this. This we call it as spring, right? This is what? Groundwater table. This is a subsurface source, right? When this phenomena happens, this water oozes out of that particular hole, tiny hole. That we call it as a spring, right? Spring indicates outcropping of groundwater table. The spring indicates natural outcropping of this groundwater table, right? Remember this, they may sometimes ask you. This is about sources of water. Okay, let us have brief idea this quality of water. This is a very very important chapter. Many in any exam, from quality of water you will have some questions definitely. Okay, look at this. What is this? Blue baby disease in children is due to presence of dash in water. Very easy, try to solve this. Blue baby disease in children is due to the presence of dash, excess nitrates. If the nitrates concentration is more than 45 milligram per liter in water, it leads to blue baby disease. It is also known as methemoglobinemia, right? Blue baby disease. How it will affect? When the nitrates concentration, if it is more than 45 milligram per liter, it leads to what? Blue baby disease or methemoglobinemia disease, right? Which one is correct? Excess nitrates. Therefore, option is D. Very easy, simple questions. See, now look at this. This is very very important Indian Standard Code. As per IS 10500 2012, the acceptable limit for fluoride in drinking water is, see, this Indian Standard Code is for water quality standard, drinking water standards, IS code, right? See, what is asking? Acceptable limit for a fluoride in drinking water. What is an acceptable limit for a fluoride in drinking water? 1 milligram per liter. What is a maximum permissible limit? That is 1.5, but he is asking acceptable limit for drinking water, right? That is what? 1 milligram per liter, right? This is the correct. See, fluoride must have 1 to 1.5. 1 milligram per liter is required for our healthy, for a dental health. If 1 milligram per liter is present, it prevents dental cavities. If it exceeds 1.5 milligram per liter, it causes dental fluorosis, which is known as mottling of teeth. Okay? If it exceeds 5 milligram per liter, it causes bone fluorosis or else skeletal fluorosis, right? This is a peculiar water quality parameter. We must have the limit between 1 to 1.5, right? Here we can say 1 is the correct answer, right? Okay, next. Try to solve the maximum permissible limit of TDS in drinking water in the absence of an alternate source as per the code. Same water quality standard code. Try to remember the code along with the year also. IS 10500 2012 water quality standard code. What is asking? The value of TDS, permissible limit, in the absence of an alternate source. When the absence of an alternate source, if you have observed these kind of wording in the question, you must select a permissible limit, not an acceptable limit. You may often take the 500 milligram per liter, but that is wrong. That is an acceptable limit for TDS. Permissible limit is how much? D. 2000 milligram per liter, that is the permissible limit. See, these water quality parameters as per this particular Indian Standard Code are very very important. Let me provide you all the important parameters at one place, so that you can able to recall when before the exam, right? Try to take a screenshot of this, my dear. Water quality parameters as per particular the code that I have mentioned, IS code. See, in that question, if they mention permissible limit in the absence of an alternate source, if they mention like that, you need to select these limits, right? See, take the screenshot of this. See, we have a color in true color units. Acceptable is 5, permissible is 15. Turbidity in nephelometric turbidity unit, NTU 1 and 5. pH is 6.5 to 8.5. Very very important water quality parameters I have taken. Take a screenshot of this. Order as per this code agreeable. TDS 500 is acceptable, but he has asked permissible limit. That's why we have taken 2000, right? Again, total alkalinity and the hardness both are 200 600. See, 200 600. Have you taken the screenshot? Okay, let me provide you one more table which includes all the important water quality parameters. See, hardness also 200 600. Permissible is this. Here we have chloride 250 1000, sulfates 200 400. See, fluoride acceptable limit is 1, permissible limit is 1.5. Nitrates, methemoglobinemia, I just now I have explained. nitrate's concentration is 45. If it crosses this value, then it leads to infantile disease, right? Methemoglobinemia. These are about all important water quality parameters. Let me give you the metals also. The last year SSC JEE, this is asked. Calcium of acceptable limit is 75 milligram per liter, right? Take the screenshot. Very, very important water quality parameters. Take the screenshot of this also. Very, very important. Okay, this is about water quality standards in that particular quality of water. Now, look at this question, try to solve in 36 seconds, my dear. Try to reply. See, hardness of water can be determined by, which method? EDTA or Versenate method, right? Hardness of water can be determined by EDTA or Versenate method. See, let me give you the water quality parameter and corresponding method of evaluation. Let us look at that. This is the properties of water. Here I have mentioned the test or an instrument to measure that particular water quality parameter. See, hardness is by EDTA or Versenate method. Very, very important it is. Hardness is by EDTA method or Versenate method. What is DO? DO is by Winkler method. What are chlorides? Chlorides by Moore method, right? These are all well known to you. Just quickly revise all these parameters. Okay. What is pH? pH is by potentiometer. What is color measuring instrument? Color is measured by tintometer, right? Tintometer. Sometimes, see here, color you know, all know tintometer. Sometimes they may ask you Nessler tubes. See, these Nessler tubes are used to measure, color of water. Remember this, Nessler tubes, right? Nessler tubes are used to measure color of water. Okay. What about taste and odor? Taste and odor can be determined by an instrument called osmoscope. Very, very important water quality parameters and the method of measurement. Okay. What is turbidity? We have many turbidity measuring devices, right? Turbidity meter, turbidity rod and nephelometer, right? This turbidity rod and turbidimeter we known as Jackson candle turbidimeter, which works on the light absorption method, but nephelometer works on the principle of light scattering technique, right? All these are turbidity measuring devices. What about bacteria count? We can use MPN test. What is MPN? Most probable number test, right? These are the various water quality parameters and the method of measurement. At one place I have given you for your easy revision. Okay, next, solve this. TCU means true color unit is an equivalent to the color produced by, solve. TCU is an equivalent to the color produced by, see, color is by a platinum, right? 1 milligram per liter of chloroplatinate ion. Is it correct? Go and next option, see, 1 milligram per liter of platinum ion. This is also next option. 1 milligram per liter of platinum in the form of chloroplatinate ion. This is the most appropriate option, right? Option C is correct. Color is by, one true color means we add 1 milligram of chloroplatinate ion, right? Platinum in the form of chloroplatinate ion in 1 liter of suspension. The color produced by that particular suspension is a standard color, that is one true color unit, right? Option C is correct. Chennai. Very easy, simple question. Next, try to solve this. In natural water, hardness is mainly caused by, look at this question very carefully. Hardness is caused by all multivalent cationic substances. Here in the options, all are multivalent cationic substances except option C. See, here you can see sodium and potassium having the ionic constant plus, right? Na plus, K plus means not a multivalent, single, right? Remaining all Ca plus plus means 2 plus, Mg2 plus, Ca2 plus, Fe2 plus, all are multivalent cationic substance. All other except the C option, all other constituents imparts hardness to water. But he is asking hardness is mainly caused by, mark this word, mainly caused by, generally calcium and magnesium are abundant minerals which we usually observe in our natural waters, right? Therefore, out of this calcium and magnesium is correct option. All are impact hardness to water, but mainly caused due to calcium and magnesium, right? Manganese, iron, all are impacting hardness, but mainly are this. Option is D, Delhi. Okay. Okay, the next question. Look at this very simple question I have taken from previous year gate. See, look at this, the alkalinity and the hardness of water sample are 250 and 350 as CaCO3 respectively. The water has, he is given the options like carbonate hardness, non-carbonate hardness. We need to estimate carbonate and non-carbonate hardness by that given data. What alkalinity he has given? What is total alkalinity? 250, hardness is 350, right? Let me solve. Total alkalinity is 250 milligram per liter, right? What is total hardness? 350 milligram per liter he has given. What about carbonate hardness? As you all know, carbonate hardness is equal to, carbonate hardness is minimum of total alkalinity and total hardness, right? Therefore, minimum of, what is total alkalinity? 250. Total hardness is 350, which is minimum here 250. Therefore, carbonate hardness is 250. If carbonate hardness is 250, what is non-carbonate hardness? Total hardness minus carbonate hardness. Very famous question it is, very easy also. Total hardness is 350 minus carbonate is 250. Therefore, non-carbonate is 100 milligram per liter as CaCO3, it is milligram per liter. Carbonate is 250, non-carbonate is 100. Which option is matching? See, 250 milligram per liter of carbonate hardness and 0, this is wrong. 250 carbonate hardness and 350, wrong. 250 milligram per liter of CH and 100 milligram per liter of NCH. Therefore, option D is correct, right? Very simple question based upon the data given. Okay. Okay, next question. A waterborne disease poliomyelitis is caused by, a waterborne disease poliomyelitis is caused by. Very easy, try to answer. You don't need 36 seconds to answer this particular question. Within 2 seconds you can able to recall, right? Polio is by virus, right? This is a viral disease. Option A is correct answer, right? Okay, let me give you waterborne diseases some idea. Let us quickly revise. See, these are various waterborne diseases we usually observe. These are the some important waterborne diseases I have listed out here. Look at this, we have typhoid and cholera. These are due to bacteria, bacterial diseases, typhoid and cholera. What about polio and jaundice? These are viral diseases, right? Polio and jaundice. What is dysentery is due to protozoa. This is protozoal disease. Remember, these are bacterial, these are viral, this is the protozoa. See, which microorganisms causes this particular disease also an important aspect. Try to recall your memory. Name of the microorganism which causes typhoid, Salmonella typhi, which causes cholera, Vibrio cholera, right? Salmonella typhi causes typhoid disease, Vibrio cholera bacteria causes cholera disease. What about polio and jaundice? Polio is by poliomyelitis virus, jaundice is by hepatitis virus, right? This is the microorganisms which causes that particular disease. What about dysentery? The protozoa is Entamoeba histolytica, very important waterborne diseases. Try to recall your memory and revise quickly, right? Important things. Okay, next. Look at this very simple question. Try to solve. Measure of the degree at which water loses its transparency due to the presence of suspended particulates. Due to the presence of the suspended particulates, water loses its transparency. Transparency means the resistance offered by that water to passage of light, right? If it lost the transparency due to the suspended solids, what is that particular water quality parameter, my dear? That is turbidity, right? Turbidity is that particular property, measure of the degree at which the water loses its transparency due to the presence of suspended solids, right. Look at this image, you can easily recall, if the water is cloudy like this, muddy water, dirty water, it contains lot of suspended solids in them. If you focus the light, it can't penetrate, it can't pass through this muddy water, you can't see the light from the other side, right. This is what the property of turbidity, right. Okay, simple question. Next, see, this seems to be difficult, but let me tell you one easy thing. See, by looking at this IS code, you may feel little discomfort, but without knowing that IS code, with a common sense, we can solve this particular question. Just look at this. See, try to solve. See, here what he is saying, which type of order characteristic, try to solve this, which type of order characteristic is not used for classifying order of a given water sample as per the IS code. For fun, just forget about this IS code mentioned here, just forget about the IS code. What is asking, which type of order characteristic is not used, which type of order characteristic is not used for classifying the order, right, not used for classifying the order. Order in the sense taste and order, right. See, the degree of pungency, right, degree of pungency means it's related to smell, therefore we can consider for classifying the order. Degree of sweetness, it relates to taste, right. Order and taste means pungency is smell, sweetness is taste related. Degree of smokiness, it is somehow related to smell, right. Therefore, all these three we can use, all these degree of characteristics can be used for classifying the order. With the common sense we can say pungency, sweetness and smokiness are related to order and taste, but only which is not related is turbidity, right. Turbidity is not related to smell or taste. Therefore, we can select without knowing this IS code, still you can able to answer these kind of questions, right. You can pick the option D is correct, right, is not a characteristic classifying the order, that is degree of turbidity, right. This is about quality of water. We have discussed all water quality parameters, one water quality parameter and the method in which we need to determine, and also some questions we solved, right. This is very important chapter, probably they may ask you questions from this area, right, in quality of water. Next, treatment of water. See, very easy, within 1 minute, within less than 30 seconds you can able to solve this kind of numericals also. See, just look at this question, try to solve. What is the surface area of settling tank used for design discharge of 1.5, discharge given is 1.5, assume overflow rate of the tank as 40, 40 is the surface overflow rate given. See, by looking at these options, you may feel the calculation is difficult because options are in decimal, but still you can get the answer very easily. To confuse you, they have given in the decimals, nothing difficult here. See, what he has given, surface area he intended to find out, right. Discharge he has given Q. What is Q? 1.5 meter cube per second he has given is Q. What is surface overflow rate? Surface overflow rate SOR is equal to 40 meter cube per meter square day. What is surface overflow rate? Overflow, surface overflow, flow of water over a surface area, right. That is what surface overflow rate. Surface overflow rate means what? Flow per surface area. Flow means discharge per surface area. I want area here. What is area? Area is equal to discharge by surface overflow rate, very easy. Now solve discharge by surface overflow rate, that will give you area. See, here I will try to solve here. Area is equal to, what is discharge given? 1.5 meter cube per second. I am converting that into days. Just solve 24 into 60 into 60. Now it is meter cube per day divided by, what is this SOR? 40. 40 in meter cube meter square per day. This is in meter cube per day. You will get the area in directly meter square, right, very easy. Now 15 by 10, try to solve on your own. 4, 6. Therefore, we can say 15 into 6 into 6 into 6, right, 90, 6, 540. Therefore, 540 into 6 means 3000 240, right. 3240, very easy calculation, 3240 meter square you are getting. Exactly you are getting 3240. Which option is matching here? Option B. To confuse you, they have given in decimals, but you are exactly getting 3240 meter square. Therefore, B is correct. Bombay. Very easy, right? Surface overflow rate, from that you need to calculate area. Next question. See, this is also easy. By looking at the options and lengthy, you may feel the lengthy question, but very easy. Try to solve. See, a set of 4 rapid gravity filter bed systems is to be designed for a town of 1 lakh population with a daily supply of 250 liter per head per day. The rate of filtration through the filter bed is, the rate of filtration is given as 5000 liter per hour per meter square. What he has given? The rate of filtration he has given. The length of the filter bed is twice that of depth. Sorry, the length of the filter bed is twice the width. He has given the relation. He is asking length as well as width of the filter bed. He has given the options here. Let me take the data first. He has given the condition L is equal to 2B. This is the condition given. Here if you can look at, all are having L is equal to 2B, you can't, by verification you can't solve. Okay, then what is the population given? P is equal to 1 lakh means 10 to the power of 5, and LPCD, what is that? 250 is the rate of supply. We can say liter per person per day, liter per capita per head, right? LPCD. Then rate of filtration is given. How much? 5000. ROF is equal to 5000 liter per hour per meter square. Liter per hour per meter square. Look at this. From the population and average supply, you can have Q, discharge, for which we need to design the filter, right? See, a set of 4 rapid gravity filters are given. A set of 4 he has given, right? 4. This is the data. What is Q? Population into per capita water supply is 250. This is liter per day. We can convert this into liter per hour, right? 10 to the power of 5 into 250 divided by 24 liter per hour. Now, if you divide discharge by rate of filtration, you will get the area. Rate of filtration means flow of water over the filter surface area. Similarly, surface overflow rate, ROF is the same, Q by surface area of the filter, similarly same. Therefore, area required is equal to, what is Q here? Q is this, 10 to the power of 5 into 250 divided by 24 is the Q. It is in liter per hour divided by surface area. Rate of filtration is 5000 into 5 into 10 cube. This is liter per hour, this is liter per hour per meter square. You will get the answer in meter square. See here, let me have 5 5s, 50, 3 zeros, right? Therefore, 500 divided by 24. For just for fun, I am assuming 24 as 25 for a simple calculation purpose. It is 24, actual value is 24, I am assuming 25 for ease of calculation. If I assuming 25, you will get 50 meter square, right? Sorry, 25. Area is equal to, see, somewhere we did a mistake, right? Liter per hour, 5000 liter per hour, 5 5s, correct? Here 50 into 10 to the power of 5 into 50, right? 20, right? 20 meter square. Let me erase this. See, look at this. 10 to the power of 250 liter per hour divided by 24 into 5 into 10 to the power of 10 cube liter per hour per meter square, 10 cube. Okay, 5 50s, 5 plus 1 6. Okay, one more 0. I forgot to put one more 0. Okay, it is 5000. Therefore, if I am assuming instead of 24, 25, 200 meter square is the area. This is the total area filter I got, but I have 4 such filters. Therefore, each bed area is area of each filter, A of each filter is equal to 200 divided by 4. It is 50 meter square is the each filter area. He has given area means L into B. L into B is equal to 50. L is equal to 2B he has given, right. Therefore, 2B into B is equal to 50. Therefore, B is equal to what? Under root 25, right. Therefore, 5 meter. What is length? L is equal to 2B. Therefore, 10 meter. See, I am considering instead of 24, 25 I have considered. Therefore, actual value will be little bit more. Whatever we have got, the length as 10 meter means little bit more of this. Width is 5 meter. Look at the options. Length is 10.2, correct, right? Little bit more. And width is 5.1. We got 510, but little bit more you will get, because actually it is 24, not 25. Right? To ease of calculation, I have considered like that. Very easy. Even though you can solve in 1 minute, it takes sometimes. Otherwise, you can easily solve. Okay, next question. Look at this question. It is also an easy question. Try to solve. A village has a population of 200 with an average rate of water demand as 100 liter per capita per day. Average rate of water demand he has given. A rapid sand filter having an average filtration rate of 100 liter per hour per meter square is to be designed for a water treatment. The area of rapid sand filter required is, he is asking what? Area of rapid sand filter. The ratio of maximum demand to average demand as 1.5. Maximum to average is 1.5, means you need to design your filter for the maximum demand, not for average demand. See, the data he has given as 200 is the population, P is equal to 200 he has given. What about supply? 100 LPCD is the supply given, rate of supply. Rapid sand filter having an average rate of filtration he has given 100 liter per hour per meter square. 100 liter per hour per meter square is the rate of filtration. Then the area of rapid sand filter required is, he is asking in meter square, you need to estimate. How can we evaluate? See, you have a discharge, right? Discharge is equal to population into per capita water supply. This is in liter per day, right? Rate of filtration 100 liter per hour per meter square, but we don't design our filter for this discharge. He has given, consider the ratio of maximum demand to average as 1.5. Therefore, design discharge is Q max we need to design. What is that design? 1.5 into 200 into 100 liter per day. This is liter per day, but ROF is in liter per hour per meter square. It is liter per day divided by 24 will give liter per hour. Solve for area, very easy. Area is equal to, I am considering 15 into 200 into 1 decimal I am removing, divided by 24 is liter per hour into, that is what, 100 liter per hour per meter square. You will get the area directly in meter square, right. Therefore, you will get 2 12s, right. Okay. 3 4s, 3 5s. 50 by 4. 50 by 4 means 12.5 meter square. Simple, right? 50 by 4, 12.5 meter square. Which option is matching? Option B. Bombay is correct. Simple questions based upon the surface overflow rate and rate of filtration, right? Okay, the next question. Look at this, very easy. Solve. The following chemical is used for coagulation. Which of the following are coagulants given? The following chemical is used for coagulation. See, aluminum sulfate, which is the coagulant given, right. See, generally we use the common coagulants as alum, aluminum sulfate, right. Look at this, the common coagulants are, just recall, aluminum sulfate, ferrous sulfate, ferric chloride and ferrous sulfate, and sodium aluminate, right. This aluminum sulfate we call it as alum. This is what? Alum. What is the chemical formula of alum? Al2 SO4 thrice 18 H2O. This is a cheap coagulant, universally accepted coagulant. Aluminum sulfate is a coagulant. These ferrous sulfate and ferric chloride and ferrous sulfate are known as iron salts. these are iron salts. This is sodium aluminate, right. This we call it as copperas, this will call it as chlorinated copperas, right. See this aluminum sulphate alum works better at a pH of 6.5 to 8.5. In this pH range alum works better, right. This is about common coagulants. Try to recall with this common coagulants, right. Okay. Just solve this question. This is an important question based upon the chlorination. What is the main reason for the pH control during disinfection? What is the main reason we are controlling the pH of water during disinfection? Try to recall, read the options given. To ensure only HCl is formed, to inhibit the reaction of the chlorine with water, we are inhibiting, we needs reaction of chlorine to water, right, no inhibition. Here, to ensure that powerful residual hypochlorous acid is formed, and to ensure a good water pH in the distribution system. Which one is correct? Just think about it and try to answer. See, what is the main reason for the pH control during disinfections? Why do we have a pH control in the disinfection means? See, look at this. If I add chlorine to water, what happens? It has to react, but it don't react when the pH is less than 5. If the pH of water more than 5, then only the chlorine reacts with the water and it forms HOCl, which is known as hypochlorous acid plus H plus Cl minus. This hypochlorous acid is a very good disinfectant. It has 80 times more disinfecting power than its ion. See, but this hypochlorous acid, the formed hypochlorous acid having more disinfecting power is highly unstable. What happens when the hypochlorous acid at a higher pH range, at an elevated pH, when the pH value more than 8, this hypochlorous acid dissociates. How it dissociates? H plus OCl minus. This OCl minus, as you can observe here, this is hypochlorite ion. The hypochlorous acid dissociates and forms its own ion, but comparatively if you say hypochlorous acid has more disinfecting power, 80 times more powerful than its ion. Therefore, we need more hypochlorous acid into our water. Therefore, it do our job more effectively. That is why we have control over the pH. Why do we control? We need this hypochlorous acid into the water, right. Therefore, which option is matching here? To ensure the powerful residual hypochlorous acid is formed, we need to control the pH. Simple. Option C, Chennai is correct. The next question. Try to solve. Which of the following process includes chlorination of water above the break point? If we add chlorine to water beyond the break point dose, we call it as superchlorination, not an excess chlorination. Excess, if you add excess chlorine beyond the break point, it does not mean excess chlorination. Excess chlorination is not a physical significance, we call it as superchlorination. What is that, my dear? Superchlorination. Okay, let me give you a brief description about the types of chlorination. What kind of chlorination, the stage at which chlorine is added, and the effect of the chlorination. We have various types of chlorination. Just try to recall your memory. These are the various types of chlorination available with us. What is plain chlorination? The only chlorination is given as a treatment to water, we call it as plain chlorination. See, the available water is very pure, good quality of water is available with us, then we only disinfect the water and supply to the community. If the only chlorination is your treatment, then we call it as plain chlorination. What is pre-chlorination? The word pre means before, right? What before? Before filtration. See, chlorination is done before filtration, we call it as pre-chlorination. See, when the organic load of water is very high, we can't apply to the filtration directly before chlorination. Therefore, when the organic load is more, to reduce the organic load, we do pre-chlorination to water, that is before filtration, right? What is post-chlorination? Chlorination done after the filtration. Generally, in the conventional water treatment plant, we do post-chlorination only. At the end of conventional water treatment, we do disinfection, right? After all the treatment is given to water, at the end disinfect the water, right? That is post-chlorination, simply known as chlorination. What is double? adding chlorine to water twice. If we do pre-chlorination, it always followed by post-chlorination. It means we are adding chlorine twice, we are giving chlorination to that particular water twice, because it is highly polluted water, highly organic load. That is why we do double chlorination twice. What is superchlorination? Just now we discussed, adding excess chlorine to water. If you add excess chlorine, that is superchlorination. Dechlorination, removal of chlorine. If any if we add chlorine for some reason, excess chlorine we added, if any excess chlorine, we need dechlorination also. It means, see, if the chlorine concentration as a residual chlorine crosses 0.2 milligram per liter, it leads to trihalomethanes, which are carcinogenic in nature. To avoid that, we do dechlorination before supplying to the community. That is what? Removal of chlorine, excess chlorine. What is break point? When the total demand of chlorine demand of water is fully satisfied, that is known by break point chlorination. At that particular dose, the water demand of water, chlorine demand of that particular water is completely satisfied. The point at which the chlorine demand has been totally satisfied, that is known as break point chlorination. Have a quick idea about these types of chlorination. They may ask you few questions from this area, right? Very easy. Okay, the next question. Chlorine demand of water is equal to chlorine demand. Try to solve. See, what is chlorine demand, my dear? See, we add a chlorine dose to water, right? Chlorine dose we add to water. What is this chlorine dose it contains? We add chlorine to water as a dose. This chlorine dose has chlorine demand. It first meet the demand of chlorine. Water has chlorine demand due to some reducing substances, iron, manganese, any other reducing substances. They consume some chlorine. That is what? Chlorine demand. After water meets all its chlorine needs, chlorine demand is fully satisfied, any chlorine in excess we need to add. That is what? Cl2 residual. This is what? Cl2 residual. This is residual chlorine. See, the chlorine dose has two components. One is demand and another one is residual. We do add residual chlorine to water to prevent the water for future contamination, right? That is why we do Cl2 residual. Here he is asking chlorine demand, means dose minus residual. Which option is matching here? Chlorine demand of water is equal to chlorine dose, chlorine residual. See, dose minus residual, A minus B is correct, right? From this expression, demand is dose minus residual. A is dose, B is residual, A minus B is correct. Simple questions on the chlorine dose. Next question. See, let me give you this water quality standard as per IS 10500. As I am emphasizing more on this particular IS code, which is very, very important. As per this particular IS 10500 and 2012, free residual chlorine. Why do we add free residual chlorine? To prevent water from future contamination, right? Therefore, acceptable limit as per that particular code is 0.2, permissible limit is 1. As per that particular code, acceptable is 0.2, permissible is 1, right? Remember this important residual chlorine standard. Next, which of the following is not a dechlorinating agent? Simple questions, my dear. 36 seconds is not even required for you, right? Simple straightforward theoretical questions are being asked for SSC JEE exam, right? You can able to pick the option in less than 10 seconds, right? You can save time in this particular environmental engineering subject, right? Okay, try to solve. Which of the following is not a dechlorinating agent? See, activated carbon is a dechlorinating agent, sulfur dioxide is also a dechlorinating agent, sodium thiosulfate is also a dechlorinating agent. Which is not? Carbon dioxide. Therefore, which is not a dechlorinating agent? Therefore, carbon dioxide is not a dechlorinating agent. D is correct, Delhi is correct. These are all dechlorinating substances, carbon dioxide is not. Next, very important, various kinds of settlings we observe in environmental engineering. Just look at this. Free settling of particles in the sedimentation process is also called free settling of particles. Free settling, he is saying free settling in the sedimentation process is also called discrete settling, right? The particle whose properties does not change with time, its size, shape does not change with time, that particle is known as discrete particle. Therefore, free settling of a particle in the sedimentation process is called discrete settling. Let me give you some idea about all the settlings we usually observe. let us look at this. We have these 4 kinds of settlings we observe. Type 1 settling is discrete settling, type 2 is the flocculent settling, type 3 is the zone or hindered settling, both are same, zone settling or hindered settling. Type 4 is compression settling. See, in the first type, discrete settling means the particle settling happens in the influence of gravity, therefore individual particles are settling down under the influence of gravity, therefore we call it that discrete settling. Where you can observe the discrete settling, which is observed in plane sedimentation, right, that is discrete settling. What about flocculent settling, my dear? Flocculent settling means we add coagulant to water to stabilize the colloidal particles. Once the stabilization process done, all those colloidal particles are coalesce with each other, means come together and become a bigger size particle, then the settlement occurs. Therefore, here the flocculent particle means the properties of that particle changes with time, discrete particle properties does not change, right. Therefore, it is type 2 settling, where you observe sedimentation aided with coagulation, right, in which you observe type 2 settling, right. Write down here type 1, type 2. What about type 3, where you observe the zone or hindered settling? See, the concentration of the particle is very high, then the particles are trying to bombard with each other, means they are hindrances are more. Hindrances means they are contacting each other due to the higher concentration. Due to that, what happens is the particles attain same relative velocity with which the particles are settling. See, the particle at a horizontal level, if you consider, all the particles are having the same horizontal velocity, it means as a zone the particles are settling, that is why it is zone settling. Due to the hindrances, they can achieve that relative velocity, same relative velocity, that is why it is hindered settling. Where you can observe in the hindered settling, my dear? You can observe in the secondary settling tank following ASP, after the aerator in the ASP, activated sludge process, then the effluent from the aeration unit will go to the secondary settling tank, in which you are observing zone or hindered settling. What is compression settling? In this compression settling, the concentration is very high, the particles are there is no gap between, physically we can't see any gap between the particle, therefore they are very close to each other. When the particles are such a closer, they are in physical contact with each other, what happens is the compression occurs, the top layer and the bottom layer. The top layer applies pressure, compressing, by squeezing out of pore water the compression happens, that is what compression settling, where you can observe the same SSD, but bottom, at the bottom of SSD following ASP trickling filter. See, these are the wastewater treatment processes, right, activated sludge process and trickling filter. At the bottom of the SSD we have this compression settling, right, and again sludge thickening process, at the sludge also we can experience the compression settling. These are the various kinds of settlings. Okay. Next, we will come to the distribution. Very easy question, it may seems to be lengthy, but he is explaining to you. What is this? In which of the following systems of water distribution, water can reach a particular point only through one route, and any damage or repair at a point in the pipeline will completely stop the water supply in that area being fed by that pipe beyond the point of damage of repair. Water is in only one single direction. Which kind of water distribution system it is? Dead end system or tree system. Very easy, my dear. Let us briefly look at the images so that you can easily able to recall your memory, right. Let us look at this. See, this is how the dead end system looks like. See, this is the main supply line, this is the line which originates from the main supply. If I close this valve, see, this area, entire area is fed by this particular network. The water is flowing in this particular one direction only. See, you can see only one valve which caters the water to all the distribution area. If any repair happens in this zone, we need to close this valve so that entire area is getting disturbed, right. That is, water is flowing in one single direction. This is what dead end system looks like, a tree, that is why it is a tree system. Where we can use, look at this, the system is adopted for the older interlaced system or reticulation system. There are 3 different names to grid iron system. In that dead end we have water flow in only one single direction, but in this case see, this is the distribution area in which water is from multiple directions. You can get the water. If you have a repair here, you can get the water from another side, right. This is the advantage of gridiron system. Where you can use this system, very important. The system is adopted for well planned city or town. Remember, well planned city or a town, we need gridiron system. Well planned city or a town. Look at this, see, gridiron system means the city is also like a grid, well planned city. It is the image of Chandigarh city in India. You can see from the top, you can see various grids. We can follow water distribution system as per that city plan, right. Here we can use gridiron system. What is ring system? Look at this, the main periphery, see, this whole distribution area is covered by the main pipe. See, this is like a periphery, the main pipe is surrounded by the distribution area, in which case we have a ring system. It is also known as circular system. Where we can use the ring system? When the city is having well planned roads. See, gridiron system is when the city is well planned city, but here specifically the system is adopted for towns and cities having well planned roads. One of the previous year service commission exam, they have clearly said for a well planned roads, circular system is adopted. For a well planned city is in the sense gridiron system. Remember this is the most confusing point here. Ring system is adopted or circular system is adopted for well planned road is this, but well planned city, it is gridiron system. Remember this carefully, otherwise you will commit a silly mistake here, okay. Radial system, see, if existing cities like this, where centrally we can fed the water, right. The pipelines are best laid by the radial method when the city or a town having system of roads emerging from different centers. When the system of roads are emerging from various centers, we can have this elevated reservoir here, we can distribute water to that particular community. That is the radial system, right. You can have the brief idea now. Okay, try to solve valves question. The valves used for the prevention of reversal of flow in a pipeline is, it prevents the flow in a reverse direction, it allows the flow in only one single direction. What kind of a valve it is? Check valve, right. See, check valve or reflex valve or non-return valve, it has three names. It prevents the reversal of flow, means it allows the flow in one single direction. What about cover valve? See, air valve is, it reduces negative pressure developed in the pipe. What about scour valve? See, scour valve removes sand and silt at the dead end of the pipe, right. Grit removal we can do with this scour valve. Butterfly valve to regulate and stop the flow in large conduit. The butter valve works like a half quarter turning movement, that is what butterfly valve. Just look at this, this is the reflex valve, check valve or non-return valve. When the water flow is like this, it is moving smoothly. When the water flow stops, it does not allow the water to return back, it will close and it prevents the reversal of water flow, right. That is why it is non-return. Once water pass through this valve, no return, that is why it is non-return valve. Why it is check valve? It checks the reverse flow, that is why it is check valve. And also reflex means back flow only, right. This is about reflex, non-return or check valve. What about this air valve? Air valve looks like this. Any partial pressure, that is the vacuum developed within the pipe, it can be released by this air valve. The negative pressures in the pipe can be revealed by this air valve, right. This is the simple air valve. With this we completed water supply engineering. Now coming to this design of sewers and sewer appurtenances, okay. See, try to solve, my dear, try to solve this question. See, design of sewers and sewer appurtenances. A town has a projected population of 80,000 spread over the area he has given. What is the area he has given? 0.6 meter square. Find the design discharge for the separate sewer line by assuming rate of water supply of 200 liter. Rate of supply is given 200, and out of this total supply 75% reaches in the sewer as wastewater. Out of total supply 75% reaches. Assume peak factor as 2. What he is asking you to find? Find the design discharge for the separate system, separate sewer line. See, what is discharge Q? Discharge Q, population 80,000, right? 80,000 population into per capita water supply is 200, therefore it is in liter per day, right? But this is the water supply, but out of which 75% will reach as a wastewater, therefore 75% I am multiplying. 75% means 3 by 4. This is an average, but we need to design the design discharge is asking what is that peak factor 2, therefore I am multiplying that with the peak factor. This is liter per day, therefore entire will be in liter per day. We need answer in meter cube per second. This is liter 10 to the power of minus 3 meter cube per day. Meter cube per day means in seconds, 24 hour, 60 minute, 60 second. If you solve this, you will get 0.28 answer. Chennai you will get, option C. If you solve this, you will get very easy to solve. Try to solve by yourself. 277 meter cube per second you will get, very easy. Option C is correct, 0.28. Next, see, look at this very easy question, try to solve. Two sewer pipes A and B having the same diameter and made of the same material. See, diameter is same and they made with the same material and laid at the bed slope of 1 in 225 and 1 in 625 respectively. Determine the ratio of their capacity QA by QB. See, sewers are designed based on the open channel, therefore discharge is equal to area into velocity as per the Mannings 1 by n r power 2 by 3 s power half, right. See, here they made of same dia means this area is constant, they made of same material means roughness coefficient is also constant, they made of same dia means R, hydraulic depth is also constant, hydraulic mean depth d by 4 in which dia is same. Therefore, you can say the discharge is directly related to bed slope S. Therefore, what he is asking? QA by QB. Simple, QA by QB is equal to what is bed slope of A? 1 by 225 divided by what is bed slope of B? 625 under root. Therefore, 625 divided by 225 root. 625 means 25, this is 15, 5 5s, 5 3s, 5 by 3 is the answer, which is matching here, option D. The ratio is D, Delhi is correct. Are you getting? The next, see, sewers must be checked for minimum velocities at their minimum hourly flows, which is equal to, we need to check our sewer lines for a minimum velocities. What is the minimum hourly flow, my dear? 1/3 of average daily flow. You need to recall your memory the minimum flows. Let me give you those things. Variation in dry weather flow. Look at this, maximum daily is 2 times an average daily, maximum hourly is 3 times an average hourly, minimum daily is this 2/3, minimum hourly is 1/3. He is asking minimum, see, minimum hourly flows which is equal to 1/3 of average flows, right. Option is C, sorry, option is B, Bombay. The next question, see, very easy questions. Design of sewers and appurtenances are also important. They mainly focusing on appurtenances more. See, look at this. Traps are used in household drainage systems too. Traps are used in household drainage system to prevent escape of foul gases from the sewage, right. Prevent entry of foul gases in the house, we use traps. Traps are worked as a water seal. It is kind of a water seal which prevents the entry of foul gases into houses, right. Look at this, the image. This is the water collecting from the home. Once it passes through the drain by like this, once it passes through this water seal, the quantity of some depth of water prevents the entry of any foul gases from this drain to the house sewer, right. This is what a trap, basic idea of trap. Okay, the next question, look at this, the the pipe which is used to carry the discharge from sanitary fittings like bathrooms, kitchens, etc. is called. What is that kind of a pipe which carries discharge from the sanitary fittings, my dear? Which is a waste pipe. See, waste pipe carries all the liquid discharge, liquid sewage from all these kind of fittings, sanitary fittings, kitchen sinks as well as bathrooms, kitchens, etc. That is what a waste pipe. Soil pipe exclusively carries human excreta. Soil pipe carries human excreta. Vent pipe. Vent pipe means it facilitates exit of foul gases which are evolved in the sewage, right. Vent pipe which facilitates exit of foul gases. Soil pipe excreta carrying. Waste pipe only liquid discharge, that is what sewage. Anti-siphonage pipe. This pipe is used to preserve water seal. Once we have a traps, right, water traps, in the traps the liquid depth is there as a water seal. To preserve the water seal depth, we use this anti-siphonage pipe, right. Here the option is A correct, right, waste pipe. Next, see, look at this characteristics of sewage. Very simple straightforward question based on the BOD test. The following data pertains to a sewage sample at a point source. Initial DO is given, final DO is given, the dilution he has given 2%. Initial DO 12, final DO is 4. What he is asking, biochemical oxygen demand of the sewage is how much? How can we solve BOD, my dear? BOD is equal to DO initial minus DO final into dilution factor, What is DO initial here? 12. DO final is 4. What is dilution factor? He has given 2% dilution. It means dilution factor is 100 by 2 means 50. 8 into 50, 400 milligram per liter. Simple, right? You need not to put your pen on the paper. You can easily select Bombay, right? Next, the standard 5-day BOD at 20 degree when compared to the ultimate BOD is, the standard 5-day BOD compared to the ultimate BOD is standard question 68%. As you all know, 5-day BOD 5 at 20 degree centigrade is equal to ultimate BOD is L into 1 minus e to the power of minus k20 into t, right. This is the known formula to you. What is asking, the standard 5-day BOD, this BOD when compared to the ultimate BOD, what is its fraction? Generally 68% you will get, 2/3, right. If you substitute k20 value of 0.23 for a 5 days, you will get the 0.68 something answer. But remember, that is what, 68. Generally it is 2/3 of ultimate BOD is the 5-day BOD. Generally 70% of the organic matter is decomposed in 5 days, we assumed. Not an assumption, you can solve also. K20 is 0.23, by considering that you can arrive at 68% only. Okay, the next question. Okay, let us look at an air pollution and control chapter, very important chapter it is. Consider the following air pollutants. What they have given these. Which of the given air pollutants is or are present in an automobile exhaust gas? Which of these air pollutants, are present in a automobile exhaust gas? See, by looking at the various air pollutants given, this PAN means peroxyacetyl nitrate, which is a secondary air pollutant. You can able to recall, right? PAN means secondary air pollutant. Secondary air pollutants are not directly emitted from an identifiable source. If you know that, whichever the option is having the 2, you can straight away eliminate. C and D are not correct, since PAN is not directly emitted into the atmosphere, it is a secondary pollutant. Therefore, out of which oxides of nitrogen, carbon dioxide, carbon monoxide, all the 3 are exhaust gases from an automobile, right. Therefore, 1, 3, 4 is correct, option A is correct. Simple question. If you identify PAN, you can eliminate these 2, out of these 2 you need to toss, right, not toss. You must know automobile exhaust has oxides of nitrogen and carbon monoxide and carbon dioxide, all the 3. Okay, many other, but among the given, these are the options, right. Okay, identify the one which is not an ozone layer depleting chemical. Which is not an ozone depleting? See, generally all halogens are ozone depleting substances. Here you can identify the all halogens. You can say methyl bromide is ozone depleting, chlorofluorocarbons are also ozone depleting, carbon tetrachloride CCl4 is also ozone depleting. Which is not ozone depleting? Copper sulfate, right? Copper sulfate is not an ozone depleting substance. Very easy. Try to recall the memory, right? Next, look at this. This question seems to be lengthy, but very simple and straightforward question. Classify the following pollutants as primary pollutants PP and secondary pollutants SP. He has given the notation PP means primary, SP means secondary. He has given dozens of pollutants here, air pollutants he has given, many number of air pollutants. See, just try to look at the options, you can simply within 3 seconds you can able to answer this question. Look at this, in the primary pollutants, carbon monoxide, particulate matter, see look at this B option, primary pollutants he is saying, ozone is secondary, you need not to look at the other things, ozone is secondary but he is saying in the primary, therefore B wrong. See, primary, carbon monoxide, particulate matter, see peroxyacetyl nitrate is secondary, he has categorized in the primary, therefore C answer is also wrong. Then PP, primary ozone again he said, option D is wrong, which is matching. If you can able to eliminate by options, you can easily say option A is correct. Need not to look at the entire options, like entire pollutants given here. By looking at the simple, ozone is not a primary, it is given, ozone is not a primary pollutant, but he is saying primary, therefore it is wrong. Like that you can eliminate the options, you can easily say within 3-4 seconds, right? Option A is correct. Next, look at this very easy question. What is the liquid form of particulate air pollutants? The liquid forms of particulate air pollutants. Fly ash is not a liquid form, it is a particulate matter but not a liquid form. Therefore, it is not correct. Dust is not a liquid form, mist is liquid but dust is not. Mist and spray, this is the liquid form of particulate matter, right? Dust is dry, fly ash is also dry, smoke and spray, smoke is dry but spray is liquid. Both these are liquid forms of particulate matter. C is correct, Chennai. Next question. Look at this, my dear, this question is easy but I am trying to give you the idea, trying to give you some idea how to frame the table to remember these noise standards, very important noise standards they may ask you from this area. Noise pollution, very this area is very important for competitive exams. Look at this, the permissible limit, permissible noise level for a commercial area at a daytime is, for a commercial area the permissible noise level in daytime is 65. Students often confuse between the values 65, 75, 55 like that they may have, right? Look at this very carefully, with this you can able to remember better. I will try to give like this. Look at this table, these are the noise standards, my dear, right? You need to remember. We have 4 different zones, right? As you already know, industrial, commercial, residential and silence zone. We need to remember the zone in this order, right? First is highly noisy, that is industry, then commercial, then residential and then silence zone. You can remember these zones in order. You need to remember only the order and you need to remember, see this is the daytime, this is the night time. Just try to remember only 75, try to remember 75, that is diamond jubilee, right? If you remember the diamond jubilee and the zones in this order, then you can easily frame the table. Just see this logic to frame the table very carefully. See, this is an industrial zone. If you want noise levels, permissible noise levels in the daytime for the corresponding zone, for the daytime deduct a 10 from this, you will get the answer 65 for commercial area. Deduct a 10 from this residential area, last value 5. For the day table, this is the diamond jubilee, right? 75. You need to remember the zones in order and this only 75. If you forget diamond jubilee, remember diamond jubilee, that is 75. Therefore, industrial area 75 minus 10 65 minus 10 55. Last value 5 only 50. For a daytime 10 10, last value 5. If you want night time, same zones in a night time, see here top 5 remaining all 10, 75 minus 5 70, remaining 10 10 10. See, are you getting the idea? You need to remember the zones in the order and you need to remember only 75. With that 75 you can able to frame this table very easily, right? here we need to deduct 10, daytime 10, 10, last value 5, night time values from the 75, 5, remaining all 10, here bottom 5, here top 5, that is you need to remember. If you remember this logic, you can easily frame this table very easily. Student often confuse 55, 65, 45 like that, right? In the exam pressure you may have the little bit of confusion, but if you can able to frame the table, you can easily pick the answer. He is asked commercial area daytime 65 decibel, residential area daytime 55, residential area night time 45, like that you can easily frame the table. If you are unable to recall these zones in order, I have one code for you, that is Indian core sector, write like this, Indian core sector, Indian industrial, core commercial, RE residential, sector में S ले लो, S means silence zone. Are you getting my point? If you are struggling to remember these zones in order, just remember this code, Indian core sector, Indian core sector, like that you need to write Indian industrial, core commercial, core में CO commercial, residential, S sector में S ले लो, S means silence zone. Like that you can remember, very very important table. Many competitive exams they are focusing the noise levels they are asking. In this way you can easily answer correctly without any confusion. Okay, let's quickly go to the next chapter, solid waste management. Okay, see, identify the type of decay processes taking place in the Bangalore and indoor methods of composting respectively. Bangalore is anaerobic method, indoor is aerobic method. Respectively he is asking, anaerobic is Bangalore, aerobic is indoor. Therefore D correct, don't select this. In respectively means he has given Bangalore and indoor. Bangalore is anaerobic, indoor is aerobic. Option D, Delhi is correct. Next, which of the following statements is correct regarding leachate? Leachate means the liquid waste which is generated in the landfill site, right? See, which is correct? It is generated in a landfill. This is the correct. It is used for the treatment of wastewater. Leachate itself is a waste. Why do we use for a water treatment? That is wrong. It can be discharged in water bodies without any treatment. Leachate is highly polluted and concentrated liquid waste generated from the landfill. We can't directly mix it to the water bodies. It can be used for the irrigation in parks, wrong, only A option is correct. Next, the best procedure for the disposal of batteries containing heavy metals. The batteries which contains heavy metals are highly carcinogenic in nature. In such case, what is the best method of disposal? Look at the options given. Disposal by landfill, no, landfill is also not safe for such heavy metals. Recycling is the best method. Open dumping is also not safe, burning is also not safe, therefore they are carcinogenic in nature, right? Therefore recycling, try to recycle, then it is good for such kind of batteries. Okay, sludge digestion, look at this, very easy questions you can easily solve. See, a sedimentation tank removes 210 kg of suspended solids per day. What will be the volume of sludge produced per day if the moisture content of sludge is 90% of weight? Moisture content he has given 95%, it means 5% solids, right? And specific gravity of wet sludge he has given 1.05 is specific gravity. What he is asking? What will be the volume of sludge produced per day? Volume of sludge. See, suspended solids removed, he has given 210 kg per day. This suspended solids means dry solids, but actually the sludge is 95% of water, 95% of water and 5% of solids. He has given the moisture content by weight, he has given, right, 95% by weight. Therefore 5% is solids. See, the sedimentation tank removes suspended solids weight of 210 kg. Therefore this 5% of solids means this 5% of total sludge weight will be 210 kg. You can say like this, sludge of 5% of the total sludge is solid, that solid removal is 210 kg. Therefore what is the sludge you will get? Simple, 210 by 0.005, therefore 5 into 100, right? you can get 4200 kg. Are you getting? This is 4200 kg of sludge. What he is asking? Volume of sludge. We are getting kg weight. What is the density he has given? Density of sludge. What is density he has given? 1.05 means 1050 kg per meter cube. Right? This is density. What is volume of sludge now? We have a weight of 4200 simple kg divided by 1050 kg per meter cube. What is the volume you will get? 1004 400, 54 200, therefore 4 meter cube. Simple school level, right? 4 meter cube. Which option is matching? There is no option matching in this particular question. It is, I have taken from the previous SSC JE, no option is matching. You can, no option is matching here, but correct answer is 4 meter cube. You can challenge that kind of questions, right? 4 meter cube is correct. Next, the moisture content of sewage sludge of two samples were reduced, reduced as follows. Sample A, the moisture reduction happens from 97 to 95, sample B 98 to 96, moisture reduction happens. Select the correct inference. There is a decrease in volume of, we need to estimate when the moisture is reducing from 97 to 96 of sample A, 98 to 96 of sample B, how much volume reduction we can get from those two samples, we need to estimate, so that you can easily go through the options. For sample A, I am doing sample A. As you know, V1 initial volume into 100 minus P1 equal to V2 into 100 minus P2. This you know, right? V1 is initial volume. What is initial moisture of sample A? 97. 100 minus 97 is 3. What is V2? 100 minus P2. Final is 95. 100 minus 95 means 5. Therefore, initial volume is equal to 5 by 3 times volume, final volume. See, the volume, V2 you need to take. Reduction in volume can be final volume, right? In terms of V2 you need to write how much reduction happens, right? Therefore, V2 is equal to 3 by 5 V1. This V2 is 3 by 5 V1 means how much reduction happens? 1 minus 3 by 5. Therefore, 2 by 5 is the reduction happens. 2 by 5 into 100 means how much? 40% reduction is happening for sample A. Similarly, solve for sample B. Sample B, I am directly putting V1 into 100 minus P1 means 2 equal to V2 into 100 minus P2 is 4. Therefore, in terms of final volume, half of the volume is reduced. Final volume is half of that. How much reduction happens? Directly we can say 50% reduction happen. There 40% reduction happens. Any option is matching here. The decrease in volume for sample A is 40%. Here both are 50 wrong. Same wrong. 40 here, 50 here. Both are 50 wrong. Both are same also wrong. There is an increase in the volume of 60. No, there is no option is matching. This is also a previous year question. We can challenge these kind of questions. But correct answer is reduction in sample A 40%. Reduction in sample B 50%, right? This is the solid waste sludge digestion questions. Now, treatment of water. This is the last I have given as a last chapter. We discussed already air pollution and noise, right? Okay, let me go through this, the last chapter quickly. Among the following treatment units, anaerobic decomposition takes place in. See, anaerobic decomposition, we can easily go through the options, right? Oxidation pond, oxidation itself aerobic only. Activated sludge, ASP is also aerobic in nature. Trickling filter is also aerobic in nature. Which is anaerobic here? Imhoff tank, right? Imhoff tank is a two-story tank. Upper story settling of solids happens and the bottom story sludge digestion happens in anaerobic state, right? Therefore, Imhoff tank is correct. Chennai is correct. Next, Imhoff cone is used to measure. Imhoff cone is used to measure settleable solids. Settleable solids can be measured by the Imhoff cone. Simple questions. See, the detention time adopted for grit chamber is of order. Detention time for a grit chamber is 1 to 3 minutes. That's it. This is the last question, I think. detention time for a grit chamber is 1 to 3 minutes. Let me give you the important units of a treatment and the corresponding detention time, so that you can able to recall, right. What are that? Look at this. Plain sedimentation is having the detention time, plain sedimentation 4 to 8 hours, right. Plain sedimentation is having the detention time 4 to 8 hours. If we aid the plain sedimentation by adding chemicals, that is what plain sedimentation aided with coagulation, then we can cut down the detention time to 2 to 4 hours, right. 4 to 8 to 2 to 4, it is coagulation. Grit channel just now just 1 minute, but 1 to 2 minute is good detention time. Septic tank 12 to 36 hours is the detention time for septic tank. Oxidation pond, it takes 1 month almost, 20 to 30 days. PST means primary settling tank in the sewage treatment, we have 1 to 2 hours of detention time. These are few units, treatment units and corresponding detention times. This is all about environmental engineering, right. We have almost, I hope that I have covered all the areas, right. Before closing this session, let me tell you one important aspect. See, this is a mega mock test, SSC JE mega mock test. We are conducting on 26th of May 2024 at the time 1 p.m. It is online mode. The registration fee is just a nominal fee we have given 100 rupee. This is for SSC JE mega mock test. Try to enroll to this test series, forward to your friends also, those who are appearing for this particular exam, so that you can avail this mega mock test on 26th of May. Note this date, 26th of May we are conducting this mega mock test, right. Okay. I hope I have covered all the concepts in the environmental engineering for your SSC JE. I wish you very all the best for your exam. Okay. Thank you.